I'm working on repairing this 2-meter all-mode rig. It's an old ICOM IC260A, which I got at a hamfest. I may do a video on this. But what this video about is this device right here. This was in a box of junk I got at a hamfest. There's no identification on it, no markings, anything. But what it does have is an N connector input, and then it's got a sample port here that comes out to a BNC on the output. I'm assuming that this is some kind of a directional coupler or with a load or a sampler of some type with a built-in load. It is 50 ohms. I measured 50 ohms input. So what I want to use this for is I want to measure the output of a transmitter, which will be this one, but the output is too high, too hot to input to my micro water here, which has a maximum input power of 10 milliwatts. So I had to do a little experiment to try to figure out what the attenuation from the input to the output port was. So what I did, I used an old Radio Shack HTX 202 running on a 12 volt power supply, and I transmitted directly into the service monitor, the HP 8920A, and I measured the power level with both high and low power settings on the HTX 202. And then I ran it through, transmitted into this sampling unit here, and I ran the output of the sampler into this Boonton micro water. It's a model 42A. And I measured the output on the 10 microwatt level. And here's what I came up with. The HTX 202 transmitting directly into the service monitor. On high at 146.0 megahertz I measured 5.75 watts. On low I measured 1.4 watts. Then I ran them through the sampler and connected them to the 8920, but the levels were too low to even measure in the service monitor. So I went to the next step and I transmitted through the sampler directly into the Boonton micro water. And what I got on the 10 microwatt full scale was, with the HTX 202 transmitting on high, I got 8.6 microwatts. On low, I got 2.4 microwatts. So then what I did is I measured the loss between going directly into the service monitor, and these are both 50 ohms, by the way. The service monitor is 50 ohms, and so is the Boonton. So they're both transmitting into the same load. On high, transmitting 5.7 watts output from the HTX 202 and measuring 8.6 microwatts on the Boonton. Calculating that, there was a loss or an attenuation of 58.25 decibel. On low, measuring 1.4 watts on the monitor, the HP 8920, and then transmitting through the sampler to the Boonton, I got 2.4 microwatts. And then calculating standard formula, 10 times the log of the power difference, I got 57.65. So they're pretty close, 58.25 dB and 57.65 dB. So what that allows me to do is I can use the Boonton watt meter here and measure the higher levels, knowing that the attenuation is going to be approximately 60 dB. So you can use this if you wanted to, for example, sample into a spectrum analyzer, or in my case a microwatt meter. But one of the purposes of this was to show that if you can see one of these at a hamfest, pick it up, because it's not marked there's no markings on it, but by doing a few simple tests you can calculate what the actual attenuation factor is between the input power coming in here and the output here coming out of the sample port. I don't know what the wattage rating is of the device inside here. There's some type of a resistive element that I measured at 50 ohms, and I don't want to go in too high a power because I imagine it's not rated at high power, but I noticed there was no heat transmitting 5 watts into it for a minute or two. There was no measurable heat. Anyway, this is a way that you can sample the output of a transmitter with a level safe enough to use in your spectrum analyzer, or in this case a microwatt meter. So keep your eye open at Hamfest, because directional couplers and samplers are always available. You see them all the time. They may not be marked in that, but pick them up anyway. You can always measure them. Anyway, that's a little tip for today.